Good morning, everyone. I am presenting teaching AI for control engineers. As you heard before, I am a PhD in mechatronics, and I am an assistant professor at Üyesi Technical University Control and Automation Engineering Department. I'm going to tell you about my experience in the course of Intelligent Control Systems at the department. I started with this course myself in the academic year 2022-2023 in the fall semester, right after the pandemic, with a face-to-face course. It was delivered for master's students of the Control Automation Engineering Department. And then we talk and we work on intelligent control. Intelligent control arises from the conventional control, but is used to deal with complex systems or problems that cannot be controlled with the traditional methods or the traditional control that we have been working, in our subjects, with classical control. It has the learning, adaptive, and the organizing function. So you might ask, what is a complex system? So maybe it's the traditional system, but these are subjected to changes in internal dynamics, parameter changes such as extra inertias, friction, changes in the environment, disturbances around. So that's what we call complex systems. Objectives of the course of Intelligent Control Systems. So we start with the fundamentals behind Intelligent Control System, week by week, a different subject. The students acquire skills in the latest technology trends, especially for modeling, design, parameter identification, and control. And we use MATLAB and Simulink all the way. We use computational efficient tools that MathWorks provides, and we do both experimental work and simulations. Very important, we engage the students in project-based learning to complete a specific project from the first week, and they have to evaluate system performance. So we try to improve engineering-oriented analysis, problem solving, and self-learning skills in the students. How MATLAB and Simulink were used in the course. So we have oriented lessons, 3 hours per week of theoretical work, and multiple examples of MATLAB and Simulink. We also present material for teaching for the students. They are called interactive live scripts. It also have extra activities. So we go with the students until some point, and then we leave some extra activities to the students to try, to make changes and evaluate performance, control performance, modeling performance. We also include videos, simulations, and real-time experiments. So we give the application-oriented part in there. The course, so many subjects. We started, with an introduction to intelligent control system, computational tools, subjects in dynamics, in modeling, machine learning, parameter identification. With the modeling, we went to linear MPC, model predictive control. We worked with some data-driven control techniques, then deep learning, reinforcement learning, and finally, and very important, 2 weeks for the students to present their own projects. We work and we make emphasis in model-based control, data-driven modeling, and data-driven control in these courses. Experiments. So we could have many experiments, but in the last year, we were working with the TC Lab that is available and is a very cheap system. So we can work in system dynamics, parameter identification, and try many of the subjects we teach with this very simple Arduino-based lab. So the experiments are done with this. How MATLAB and Simulink were used in the course. So we are also asking the students to use MATLAB and Simulink course as an assignment and learning some courses on RAMP. We engage in project-based learning to complete a specific project and assess performance. All the students must write a report, a kind of conference paper, 5 pages, make a presentation of their projects. Why are we working with MATLAB and Simulink? What is the reason for adopting MATLAB and Simulink? Because it's high-level programming language and it comes with a full engineering development environment. It's very easy and very fast for prototyping, includes multiple engineering functions, add-on products, and ready toolboxes. It offers options to analyze, visualize, develop algorithms, and create mathematical models. Me, myself, I very much like Simulink and MATLAB. Of course, working with Simulink with the ready blocks that are coming already with programs, and the physical environment of Simscape. So there is a huge opportunity for us to try our controllers with Simscape. Multiple ready examples from everywhere on internet in the courses. The very good academic support of MathWorks and the huge community behind. When I started this course, I started with Marco Rossi from MathWorks, from the academic support. I must say, that we created the course together from the very beginning with the help of Julia Horner. Week by week, what we were going to show, what we were going to guide, how to guide our students, and also Mel Daulosol from MathWorks from the USA, from England, and from Italy. I had full support for the course. I thank them very much. These are the courses that I asked the students to take initially: Control Design on RAMP, just 1 hour, Machine Learning 2 hours, Deep Learning 2 hours, and Reinforcement Learning on RAMP. This is a must. And the students have to provide the certificate of these courses. They are free for the students, of course, if we have the license. So there are also extra courses, longer courses, that if the student wants to go deep inside, they can learn more. Another benefit added to the use of MATLAB and Simulink, the MathWorks Excellence in Innovation projects. So from the week 1, we introduced the students to the list of projects, inspiring projects based on industry. So with these projects, we as teachers and the students learn about technological trends and how to become familiar with new subject and technical projects. Also, we can help to improve, we can make it original, we can have one of these projects make changes, make it somehow original, and you can also have some recognition from leaders at MathWorks. So if you go in this link, you are going to have many subjects in artificial intelligence, computer vision, drones, robotics. So we benefit from that. Our students benefit from MATLAB and Simulink because many of their internships, part-time jobs, and extra, when they even go to an interview looking for a job, these companies, there are many more. I just got some examples here and asking the students to have. They are asking straight away if they can use MATLAB and Simulink. Some of them by Carrefour, FEV, Tuvitac, TUSASH. We have the opportunity to work with LIPAF, Sinai, ODACLI projects. Here I have an example: firefighter F-16 aircraft model. We simulate the flight dynamics in swarming coordination concept with autopilot, and we use MPC, model predictive control. So first, we design one of the aircrafts and the multiple aircrafts in the environment, avoid obstacles, regenerate trajectories, all have to pass through this green dot. This is just one of the examples. I don't have much time, but I just wanted to show you an example about it. Benefits. Our students can go to competitions in MathWorks. So we also tried that one in 2022. We got the first place in the mini drone competition.
Please, Claudia Yaşar, your last 5 minutes.
Yeah. Results obtained. Okay. Since we are presenting the final project, the students are presenting the final projects. Here I have 5 very important projects from the last course: applied in robotics, time series, applying in regression, Simscape and MPCs, Simulink and NPCs, they were all selected as the best projects in the course by me and by MathWorks. So the best projects got a recognition and a certificate. We also have 3 of those best projects as a file exchange, so people can benefit, download, they are explained, they have live scripts, so now available for the community. We also present 2 of the projects in the talk conference, as a talk conference papers. One of them is in stream seeking and used for control by Berkenbural. We also apply MPC for a differential robot. It was also a talk conference. We have 2 papers in process now because this extended version of the work that the students presented. What else we have for the future? So we are enhancing, and we are in the 4th week of the 2nd version of the course, Introduction to Intelligent Control System. We plan a webinar in March. We are developing new material. We carry on with online trainings, MATLAB applications, and using different tools for online learning. And we are adding more real-time experiments to our courses. So algorithm with cameras now. Also, we carry on with the TC Lab, and we have a new platform working with motors, to work with robotic systems. Thanks a lot.